Welcome to LeetCode Problem 217, contains duplicate. Let's understand what we need to solve. We are given an integer array called nums. Our task is to return true if any value appears at least twice. We return false if every element is distinct. This means we need to check for duplicates. Now, let's look at the constraints. The array can have 1 to 10 raised to 5 elements. Each number can be from -10 raised to 9 to +10 raised to 9. These are important to consider for our solution. Let's look at our first example. The input array is 1, 2, 3, 1. The output is true. Why is this true? Notice the value 1 appears twice in the array. It's at index 0 and also at index 3. Since we found a duplicate value, we return true. This is a straightforward case where duplicates exist. Now, let's see example 2. The input array is 1, 2, 3, 4. The output is false. Why do we return false? Look at the array carefully. All elements are distinct. The numbers 1, 2, 3, and 4 each appear only once. There are no duplicates in this array, so we return false. This is the opposite case from example 1. Let's start with the brute force approach. The main idea is simple. We compare every element with every other element in the array. Here's how it works. Step 1. We use nested loops to check all pairs. Step 2. The outer loop iterates through each element at index I. Step 3. The inner loop compares with remaining elements at index j. Step 4. If we find that nums at I equals nums at j, we return true immediately. Step 5. If we finish all comparisons without finding duplicates, we return false. This approach checks every possible pair. Now, let's look at the brute force code. We define a function called contains_duplicate that takes nums as input. First, we store the length of the array in variable n. Then we start the outer loop. For I in range n, we iterate through each element. Inside, we have the inner loop. For j in range I plus 1 to n, we check remaining elements. Notice j starts at I plus 1. This avoids comparing an element with itself. If nums at index I equals nums at index j, we found a duplicate. We immediately return true. If both loops complete without finding duplicates, we return false. This means all elements are distinct. Let's analyze the brute force complexity. First, the time complexity is big O of n squared. Why is this? The outer loop runs n times. For each iteration, the inner loop runs fewer times. It runs n-1, then n-2, down to 1 time. The total number of comparisons is n times n-1 divided by 2. This simplifies to approximately big O of n squared. Now for space complexity, it's big O of 1. We only use a few variables like I, j, and n. No extra data structures are needed. This makes it constant space. Now, let's explore the optimal approach. The main idea is to use a hash set to track scene elements. What's the key insight here? A hash set provides big O of 1 lookup time. This means we can check if we've seen an element before instantly. Here are the steps. Step 1. Create an empty hash set. Step 2. For each element in the array, check if it's already in the set. If yes, we found a duplicate and return true. Step 3. If the element is not in the set, add it to the set and continue. Step 4. If the loop completes without finding duplicates, return false. This approach only requires one pass through the array. Here's the optimal code implementation. We define the function contains_duplicate. First, we create an empty set called scene. This will store all elements we've encountered. Now, we iterate through the array. For number in nums, we check each element. If number is already in the scene set, we found a duplicate. We immediately return true. If number is not in the set, we add it to scene set. If we check all elements and reach the end, there are no duplicates. We return false. Notice how clean and simple this code is compared to brute force. Let's analyze the optimal complexity. The time complexity is big O of n.
Here's why.
We iterate through the array once, visiting n elements. Each lookup in the hash set takes big O of 1 time. Each insertion in the hash set also takes big O of 1 time. So the total is big O of n times big O of 1, which equals big O of n. Now for space complexity, it's big O of n. The hash set can store up to n elements. In the worst case, all elements are distinct. We would store every single element in the set. This uses big O of n space. Finally, let's compare both approaches in a table. Looking at the approach column, we have brute force and optimal hash set. For time complexity, brute force is big O of n squared. The optimal approach is big O of n. For space complexity, brute force uses big O of 1. The optimal approach uses big O of n. What can we conclude? The hash set dramatically improves time complexity. We trade extra space for much faster execution. For large arrays, this trade-off is absolutely worth it. And that's how we solve the contains duplicate problem efficiently. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.